Let's assume I don't have any technical knowledge and I've never write one line of code. The only thing I need to do is that go to the website and say write the game Tetris in Python. For those of you who doesn't know, Tetris is a game that is a building block and try to matches one column or row. I'm seeing some thoughts, or basically a chain of thoughts in here that go over different things like drafting the code, highlighting the code quality, setting up the environment, crafting the Tetris game, and it's taking a little bit of time. Something around like 50 seconds or so for the thought process in here, like 35 seconds, and then it actually write the code for me. So let's actually copy the code and then try to run and see if it actually works. So I'm gonna paste it in my code editor, and yeah, it is actually running the code, and then I can actually work with it to basically get the result that I want. It actually created different components for me, and I can actually change the positioning and actually put everything. Just notice that what I wrote, just write the code of Tetris, and it's actually working, and it creating the score for me and everything. If you think that's just for coding, here's another example to solve a PhD level mathematic problem. So here it has some equations in latex format, set of rectangular boxes, surface area, and then the radius of a smallest sphere contain rectangular boxes. So many complexity. I want you to notice that how carefully formatted is this tile and the complexity of the problem and how we come up with the solution for mathematical problems. So if you haven't seen my previous video, you know that this kind of mathematical problem is actually very hard by nature to solve from a language perspective, which is just trying to predict the next token. Is this AGI? We will answer this in this video, so stay tuned as I will go over what is this O1 model. Is this a groundbreaking result, and how is it actually changing everything, and what we need to consider when we are seeing this evolvement this fast, and how we are needing to adapt ourselves to this situation that is happening ahead of us. So without further ado, let's jump right into it. Welcome everyone to your channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Pedro Magan. I have a PhD in AI and machine learning, and this channel we talk about AI and machine learning in our everyday life. This week, when OpenAI announced their newest model O1, I actually posted something in LinkedIn which talk about the difference of the inference time scaling and training compute and the amount of time that we put during the training. And I have actually talked about what are the difference, how much right now they have put effort on a pre-training and kind of like post-training for the alignment, and then a little bit very small amount of time and compute for the inference, and how this O1 model is actually changing the whole thing by putting a lot of effort on the inference time. If you want to get informed about the latest advancement in AI and you want to know what is going on in this area, make sure to subscribe to the newsletter that I put in the description of the video. It is completely for free. OpenAI recently announced O1 model, which previously was known as a strawberry, and it actually considered a groundbreaking result. And that's the reason they call it O1, because they didn't want to continue from the previous counting. And since it's actually a groundbreaking result, and it actually one step towards AGI, they try to call it O1, and it's performed enormously better compared to the previous result. And the reason is, if you want to consider in a simplified way, when you want to learn a concept, how you do, you spend some time trying to learn a topic, and then after that, when a question is given to you, you will try to think about that problem at that moment and try to come up with a solution, right? That's how it works. So the first part, when you are learning, would be considered the training time that we consider for the large language model, and then we have some inference time, or the time that is given to you when you have the problem and you want to walk through it and try to provide your reasoning, and that's what we call like the chain of thought or the inference compute. So how we worked before was that a lot of resources and compute was given to the first part, which was the training, and we have like the different models like GPT-2, GPT-3, GPT-4, and probably GPT-5 that we might see by the end of this year. Is only about the complexity of the network that is used during the training. But what makes O1 a complete different approach is that instead of working much on the training part, it actually works on the inference. So as us, when we learned something and trained something, when we are asked a question, we cannot just answer right off the bat or try to answer like without thinking. We also try to break down the problem into simpler problems and then try to solve it in a step-by-step manner. And that's how it is going to be done right now. The first thing that we saw is that learning to reason with language models. So we have seen this chain of thoughts before. That was something as a byproduct, same as like a RAG architecture, which tried to improve the results of the currently developed model. So how it worked was that we asked the basically language model, large language models, to actually provide the reasoning how they will solve the problem, and then try to solve the problem instead of spitting out all of the responses at the very beginning, which actually also align with what we have. But what happened in this O1 is that they try to learn those steps during the training, and how it is happening is very genius in here, because they didn't try to do a supervised learning in here. And for example, they have some experts that try to label how they actually think, and then try to align the language models to basically replicate those responses. Because in that case, you would get at most the performance of human. But what's the result, or what the goal of an AGI is, that to surpass or at least be similar to the expert human level in all of the different topics. And I've mentioned it in the previous video, in order to make a result that is better than human, you definitely cannot do supervised learning. You need to work on something called reinforcement learning. So reinforcement learning is something that helps you to achieve some policy or some reasoning that you don't necessarily know. It is the magic of exploration and trying different things to come up with something that definitely works better. So how it works, and in a simplified way, is that the genius work behind this O1 was the fact that they try to run different models and then they try to ask it to come up with some reasoning, right? And then they try to have a reward function that penalize or reward some of this reasoning that result in some of the output that were correct. So we have a very complex problem. Obviously, this kind of chain of thought is actually very important in more complex or PhD level responses, and then they give it during the training, and then they try to ask the model to actually provide some reasoning, as if what we have right now. But this basically is in a one-shot or few-shot learning. But what they do is that when they render multiple of these large language responses, then they try to scoop the responses that result in some output that was correct. So basically, the reasoning that we are seeing right now doesn't necessarily align with what a human or an expert would think. So it might come up with some gibberish or something that only makes sense to the large language model, which resulted later on to some good responses, because they kind of like prioritize or put some reward for the intermediate steps or the reasonings that result in some final output that were correct. We saw that for this O1 model, the temperature are set higher compared to the, for example, the online model that is available for everyone. So the temperature is a way to show how much creativity you want to get from the response. And as we can kind of expect, we want to see some different creativity or some more exploration in the design steps, because or in the during the thought process, because we want to later on get some response as an output that is basically related or kind of correlated to the correct response. So you might see that some of your results will actually get a good response, but then sometime if you ask the same question again, maybe it won't get the same response or the correct response to you. So very quickly, if you look at the thing that they published in OpenAI, they mentioned that it is positioned in actually comparing to the 500 students in the US qualifier and the PhD level for different topics, physics, biology, chemistry, and so on, and it actually provide the best result. And I want to basically note the chart in here, which is actually very important. So what we can see on the left side is the train time compute, or basically the time in the beginning, and on the y-axis we can see the accuracy, and we can see so the training time compute is actually the log scale. We see a line in here that basically as we put more compute, we can expect to get more accuracy. That's kind of expected and what we see from the different GPT models. But what's more crazy and important is a plot on the right side, which is basically the test time compute, again in log scale, and then the accuracy, and we see the line relationship there, that the more time you put during the inference time, the more accuracy you can get. And you can kind of see in comparison that the slope of the line for the test is much higher than the training one, which means that if you put much more time during the test or inference time, the result that you get down the road is actually much higher. And that's the magic of O1. And also, we don't see that much of a plateau in here. We don't see that after some time the performance is gonna like saturate. It is actually completely aligned, and we don't see any like where we can stop it. So kind of showing that we can get better. Even like the O1 model, there is nothing to stop it. The more compute you allocate to it, the more time you wait, these models are going to provide better and better response, at least based on this competition that they have so far. And here also another comparison, which is actually very crazy. We can see that the GPT-4, the one that is the best result in the competition mass AIME, it provide like 4 to 5 times better the O1 preview model, not the O1, and the O1 actually provide 83. So this is not a like insignificant or a little bit better. It is increasing, definitely completely outworking results. So it is showing that we are one step closer to the whole AGI. Some of them mentioned that it is not the AGI yet because of the things that I mentioned about the temperature setting and the fact that it cannot get the response all of the time correctly, and then you don't have control over what they're doing in the middle steps. But this is not just math. We see it on code competition from 11 to 62. That is 6 times better than the response that the GPT-4o or the latest model could get. And then other things like the science quotient, 56 gets to 78, and then the human level was a little bit higher. So the human level, the people that are expert in one of the specific topics, not definitely all of them, one specific topic, the response that they get was about around 69. But these models, one model can get 78 across all of the different approaches. So these are actually showing the importance on how these models can improve the performance. And then here we also see another result, which basically comparing the GPT-4o and O1 improvement, and we see not just in one category, in ML benchmark, in exams, in MLU category, in PhD level science, in almost all of them we see progress, or is still like the same. So this kind of showing that this is not just experting in one thing, because as you already know, we can develop some domain specific fine-tuning, and that's something that people are doing, and that's totally fine. You can develop something that is good at doing one task, but what's AGI is that it is good on multiple different things, and that's definitely something that we can see in this model. So here is the result, and then they also talk about the strategic of a chain of thought, and we already have talked about this, but let's take a look at the at the comparison for the GPT-4o and GPT-4o preview on the different concepts in here. For example, the coding. For example, like write a bash script that do this matrix, and then here we can see the response of chain of thought. So if you look at the different steps, we can see some intermediate steps, and this intermediate step can actually be very high. You can definitely look at it, for example, for this math problem, and then if I look at the chain of thought, you see that there is a lot of steps happening in order to get the final response. So this means that it requires a lot of pre-processing, a lot of time thoughts during the inference in order to finalize the actual response to us. They hide the chain of thoughts, and what's the reason is because they don't want some other people to use that to actually come up with a model with a supervised method, right? And that actually kind of makes sense, because this chain of thoughts, if it was the whole raw chain of thought, it basically create the road for the other language models to just use that as a supervised learning and try to work on top of that. Here there's other comparison in terms of so what does this mean for us? Does it mean that the world is going to end? Does it mean that we're gonna lose our job and everything? Well, basically the answer to that is kind of complex, and nobody knows at this moment that what's gonna happen. But something that is clear is that these large language models are evolving really fast, and they are actually providing groundbreaking results sooner than we thought. So as we can see, this AI is something that is not going away. And if you know something that happens like 20 years ago from the internet, the history is repeating itself. In my previous video, I've talked about the fact that if you want to become an AI engineer right now, the hard skills are not that much of important right now, and it's more about the communication skills. So if you improve your soft skills right now while maintaining your hard skill, this is something that's gonna make you ahead of other ones. So same thing in here. You need to know how to use this knowledge in your everyday life, because later down the road, this gonna be integrated in your workflow. So what we would suggest is that try to follow this kind of advancement and try to somehow make yourself familiar with these concepts and learn how you can utilize them. The sooner the better. What you can do is that subscribe to the channel and then learn about the latest importance and advancements in AI and lots of other community that right now we have a lot of them to learn what is happening and how you can get yourself prepared. So definitely something that we can expect to happen is that we are going to see some low-level programming, some low-level task, not necessarily in programming, some low-level task is going to be replaced by AI, and then we need some higher-level knowledge and some project management, some high-level thoughts or structure to be more important, and how you communicate and get the results done with LLM and also your peers. At the end, I want to talk about the reasoning models for one that OpenAI also discussed in their model. So they actually mentioned that they are ranked in the 89th percentile in competitive programming questions. So that actually is insane. So it is almost 90%, so only 10% of other coders are actually performing the results that are better. So here there are two models, so O1, meaning what I actually wanted to quickly mention is basically a little bit about the limitation. So the modality right now, it is only text, but of course it's gonna include the images later down the road. We have the message type, so basically the assistant message is only available. These are for the APIs, and the streaming is not supported. And the reason is obvious, because they don't want you to see what is the actual chain of thoughts of the model, and then the tools, so function calling and responses are not supported yet, and then the log, and then the temperature. So I already talked about it. The temperature is set a little bit higher to get more creative, and then the batch responses that are not supported in the API. And here they talk about how the reasoning is working. So they ask the model to think and break down the response into something that they think it is required to answer the question. So not necessarily all of the responses may make sense for us. It might sound some of them to be gibberish, but it is important, and they get some higher reward for them because it leads to a good response. And then the other more important thing that I want to talk about is advice on prompting. This is the last important thing I want to talk about, is that so what we need to keep in mind when we are talking. The first thing is that keep the prompt simple and direct. So we saw a lot of videos before that talk about, okay, what is the best way that you talk to an LLM? What are the most important prompt engineering? You need to be very complementary include as much as information as you can to be more specific, but that actually completely changed right now, because you shouldn't talk too much and give too much information because it's gonna mislead. So right now they said that to be as simple as possible. You saw that in the beginning of the video, just write play the Tetris video. So that is how it's gonna be right now as well. So you need to have a very simple problem and be as direct as possible. Avoid chain of thoughts. So we talk about it, like the chain of thoughts was important. The using, for example, different steps for a few shot learning was important right now, so that no chain of thoughts, it will be done automatically. Use delimiter for clarity. We have mentioned that before, so that is still the same. Use, for example, 3-char in order to separate different components of your code. That is actually important for them. And finally, limited additional context in RAG. So before, one of the to-go ways to actually provide the LLMs to get the response basically specific to your test case, or make it personalized to your case, was simply using a RAG architecture, which basically retrieves some of the relevant information and pass it as an additional context to your context window. But right now they mentioned that you need to use limited amount, which means that you should just use the one that is very, very closely related. Previously we used, like, for example, 3 top responses, 4 responses, and the chunk size might be larger, but right now it says that use the one that are exactly important. So it's kind of, right now we need to think what are the chunks from our database are relevant, and just retrieve those, and don't be overcomplicating the response. And there you have it, guys. I went over O1 model and how it is conceptually different from the previous model, and how we are going to be aligned in the area of AGI, and how we should be prepared for that. If you want to get more information about how to get prepared in this AI area to become an AI engineer, or get some more information about this AI, make sure to watch this video that I created before. And if you're technical and you want to learn more about reinforcement learning and how it is actually can improve the base result of the human, watch this video that I try to develop a RL model for a squid hunt environment. Thanks for watching until the end of the video. If you enjoyed, make sure to like the video, and more importantly, subscribe to the channel. Thank you, and see you until the next one.